Hey everybody, welcome back to another anatomy video. In this video, I'm going to be going over the ear model, which is hopefully a model that you're at least somewhat familiar with at this point. Following the video, just as in all my other videos, I'm going to have a testing portion at the end where I will throw the model up. I'll point to a specific structure. You can go ahead and pause the video at home and answer the question, hit play, and then I will go ahead and actually throw the answer up on the screen for you. Just as I recommend with all my videos, I would say that as opposed to just saying the answer, that you also write it down because it will help you recall the information better, not just during your study sessions, but also during the exam as well. And you're going to need to know how to spell these anyways, so it's just a good habit to get into. So without much further ado, though, let's just go ahead and jump right on into the lesson. So before we get started with this lesson, I want you to understand that the ear can be divided up into three different regions. We have an external ear, which is out here, a middle ear, and then an inner ear. The very first structure that's going to be talked about when we're looking at the external ear is going to be the auricle or the pinna. And what this is, it's essentially the part of the ear that we're all able to see, and it allows for us to be able to pick up sound and direct it into this external auditory canal right here. When the sound comes in the external auditory canal, it's going to beat against this membrane right here, known as the tympanic membrane, commonly referred to as the eardrum, and that's going to be the end of the outer ear region. So now moving on into the middle ear, I'm actually going to blow this image up a little bit for you so you can get a closer look. The middle ear is this region right here, and it's comprised of bones known as ossicles. There's three different bones. We have the malleus right here, the incus right here, and then the stapes, which is actually it looks like a stirrup, and it's taken off of this model. It fell off on my model, so actually I'm just going to show you what it looks like in another image. So that's the stapes right there. I've seen a lot of students get confused in terms of putting these bones in order, and one way that I like to remember it is I just think of if you were talking to a lady and she wasn't speaking loud enough, you might say, "Miss, I can't hear you." Obviously, minus the final S on the end of miss, that's what I use. So miss meaning malleus, right? And then incus is the I, and then stapes is the S. So if you can just remember miss, I can't hear you for the exam, that might be able to jog your memory if you get a little flustered while you're trying to remember these. The function of the ossicles, though, the malleus, the incus, and the stapes, is to help to amplify the sound that's going to be eventually going into the cochlea, which is where hearing actually takes place. And if you can visualize this, it's not too hard to see why. This sound is all coming in and being picked up by a pretty large surface area right here on the tympanic membrane, and then it's causing the malleus to resonate, then that hits the incus, and then that hits the stapes. And the stapes, if we go back, is a pretty small surface area compared to the tympanic membrane. And as such, these vibrations are all essentially centered and focused on a much smaller surface area, which allows for higher amplification. Actually, it's about 20 times higher than what we had when it hit the tympanic membrane. And so the stapes is going to beat against a window right here on the at the vestibule that leads into the cochlea, known as the oval window. So this is the oval window right here, which the stapes is going to be beating against to help produce sound, and we'll get into just how it does that in just a minute. Below the oval window, we see a structure down here known as the round window, and those are the two different windows, and if you just look at the shape of them, it should be pretty obvious which one's the oval window versus which one's the round window. The oval window is the one that the stapes is going to be beating against, so it does not beat against the round window. The cochlea right here, the vestibule right here, and the semicircular canals all comprise the inner ear. And whereas the cochlea is the site where hearing occurs, the vestibule and the semicircular canals are used for balance. I also just want to let you know right now, in case you haven't picked up on this, I actually removed the inner ear from where it normally sits inside of the ear. It normally sits looking like this, but I've just pulled it out so you can see these structures a little bit better. So before I talk about exactly how hearing occurs, I first want to break down the makeup of the vestibule, the semicircular canals, and the cochlea in terms of the fact that they are all comprised of something known as bony labyrinth as well as membranous labyrinth. And what bony labyrinth is, it's essentially this outer shell, okay, of bone that we see surrounding everything, even the cochlea as well. And then inside of that is a structure known as the membranous labyrinth. And kind of the way that I like to think about this is, imagine you have this hollow bone structure that you've essentially put this inner tube in, if you want to use that analogy, and then inflated it. So the inner tube itself would be this membranous labyrinth that runs through all of these structures, even inside of the cochlea as well. And then the bony labyrinth is just the bony shell which contains that membranous labyrinth. There are two different types of fluid that we find in the ear as well that are referred to as either perilymph or endolymph. Hopefully you are aware by this point in the course that peri means to wrap around or go around the outside of something, whereas endo means to be on the inside. And so perilymph would exist in the bony labyrinth, right out here, and endolymph would exist inside the membranous labyrinth. And that's really all that there is to it, at least for this course. So it seems a little overwhelming, but it's really not. Perilymph is just on the outside in the bony labyrinth, and endolymph is inside the membranous labyrinth. Again, I'm just pointing here up to in the semicircular canal region, but again, this is happening in the vestibule, and it's also happening in the cochlea as well. So next, we'll talk about exactly how hearing takes place, and I'll be using this model to show you that. And this model confuses the heck out of a lot of people, and it's totally understandable. If you don't know what you're looking at, this thing can be very confusing. So in order to show you exactly what you're viewing here, I'm going to actually go back to this image. And again, this was the cochlea right here. It's all wrapped up almost like a snail shell. And it's made of three different compartments, if you will. On the very top, we have a compartment known as the scala vestibuli. In the middle, we have an area known as the cochlear duct. And then on the bottom, we would have an area known as the scala tympani. And so sound would come in, and it would first resonate fluid in the scala vestibuli, which would wrap all the way around and keep going and keep going and keep going until it gets to the center. And then it would come back through the scala tympani. This image itself is actually this cross section that we see right here. So if you were to take the cochlea and just do a nice cut right through it, we would get this model right here. And so this would be the scala vestibuli. This would be the scala tympani. This would be your cochlear duct. And then we have a few other structures here that we'll talk about. We have our vestibular membrane, which makes sense because if you have the scala vestibuli up here, the vestibular membrane would be attached to that. And then the scala tympani, this would be the tympanic membrane, which makes sense because you want the tympanic membrane associated with the scala tympani. We also see this membrane right here, known as the tectorial membrane. And that's actually going to be what the hair cells, which are these structures right here, are going to be bending against to produce sound. The hair cells have associated with them cells known as supporting cells, which you see down here. And so, again, when we were talking before about perilymph versus endolymph, again, this would be part of the bony labyrinth. This would be part of the bony labyrinth as well. And if you remember, the bony labyrinth is associated with the fluid known as perilymph, because peri is on the outside, whereas the cochlear duct would be part of the membranous labyrinth. Remember that inner tube that I talked about that essentially runs through the structure? That was the analogy that I gave you. And so the cochlear duct is going to be filled with a fluid known as endolymph. So now getting on to exactly how hearing occurs. Hearing occurs due to the movement of these fluids, the perilymph and the endolymph, and I'll explain that right now. Again, looking at this model, the stapes is going to beat against that oval window and begin a vibration in the perilymph of the scala vestibuli. And that fluid is going to vibrate all the way through the cochlea till it gets to the center, where it's then going to cause vibration of the fluid in the scala tympani, which is going to be coming back out like this. And so, again, the fluid first moves in the scala vestibuli, then in the scala tympani. As it's moving in the scala tympani, it's going to cause this tympanic membrane to vibrate up and down. And as it does so, it's actually going to force the stereocilia, which are attached to the hair cells themselves, to bend against this tectorial membrane. And as the stereocilia bend, they send an electrical impulse through this nerve right here, which is going to end up as eventually as the vestibular cochlear nerve, or cranial nerve 8. And we can see that nerve right here. So I'll walk you through all of that real quickly in an orderly fashion one more time. Before I do that, I did fail to mention at the beginning of this lesson this eustachian tube, also known as the auditory tube. And what this is a tube that runs from the middle ear all the way down into the nasopharynx, the superior portion of the throat. And what it allows for is us to equalize pressure inside this middle ear. So I'm sure you're all familiar with the fact that if you yawn or swallow something, you can actually change the pressure inside of your ear. And the way that this happens is because this tube is normally closed at the nasopharynx region, but when you yawn or you swallow something, it actually opens up and allows for the pressure inside this middle ear to equalize that of the atmospheric pressure. So that's what we see going on with this auditory or eustachian tube. All right, so now we're going to go in a very straightforward order of exactly how we hear, just a quick overall recap of everything that was discussed in this video. Sound is going to come in, is going to be picked up by the auricle or the pinna and directed into the external auditory canal. Once it's inside here, it's going to beat against this tympanic membrane, also known as the eardrum. When it beats against this tympanic membrane, it's going to cause the ossicles to vibrate, specifically in order. The malleus is going to vibrate, causing then the incus to vibrate, which will then cause the stapes, which was that stirrup-looking bone that came off on this model. The stapes is then going to beat against this oval window right here in the vestibule, which then produces a vibration in the perilymph of the scala vestibuli, which we see right here. That perilymph is then going to vibrate all the way through the cochlea, and when it ends, it's going to cause vibration in the perilymph of the scala tympani, which goes around and out like this. We see the scala tympani right here. The vibration of the perilymph in the scala tympani causes the tympanic membrane to vibrate up and down, which in turn causes the hair cells, and more specifically the stereocilia that are attached to the hair cells, to bend against this tectorial membrane. When that happens, it causes the hair cells to send an electrical impulse through this nerve, which will eventually become this vestibular cochlear nerve, also known as cranial nerve 8. Those impulses are then picked up in the brain, and that's how we hear. Okay, so that was the lesson portion of this video. Next, we're going to jump into the testing portion. So if you have a pen and paper, I would recommend getting that out right now, because, again, I do recommend definitely writing down these answers so you know how to properly spell them. If you're new to YouTube or you don't use it that frequently, something that you can do, as opposed to having to constantly use your mouse to find the pause and play button and hit that, if you just actually hit the space bar, it'll pause the video, and then if you hit the space bar again, it will go ahead and resume the video as well. So it's a little quick tip, make things a little bit easier for you. But best of luck, and let's jump into it. All right, so to first start, let's go ahead. Can you name this structure right here? Its job is to bring the sound into this region. Okay, this is going to be known as the auricle or the pinna. It's the part of the ear that we're able to actually see. Please name this structure right here. That's going to be the external auditory canal. Please name this membrane right here. This membrane is known as the tympanic membrane, also referred to as the eardrum. From the tympanic membrane out to the pinna comprises which part of the ear? That's going to be the external or outer ear. Moving on in, can you name these three bones in order, the last one being this one? Okay, this is going to be the malleus, then the incus, and then the stapes would be this final one, which again is right here. Collectively, what are these three bones known as? These bones are referred to as the ossicles. The ossicles are in which area or region of the ear? They are found in the middle ear. Please name this structure right here. It allows for us to equalize pressure inside of the middle ear. This structure is known as the auditory or eustachian tube. Next, we're going to look at this structure. I'm going to pull it out though, so you can see it a little bit better right here. Please name this structure right here. Okay, that's known as the oval window. And which bone of the ossicles beats against this oval window? That would be the stapes. The stapes beats against this oval window. Please name this structure right here. Okay, this is going to be known as the round window. Again, if you're taking the exam, the oval window is called oval because it looks oval, whereas the round window is called the round window because it looks round. Please name this region right here. This region is known as the vestibule. Please name these structures right here. Okay, those are known as the semicircular canals. And please name this structure right here. Okay, that is known as the cochlea. The cochlea, the vestibule, and the semicircular canals all serve different functions inside of the ear. What is the function of the vestibule and the semicircular canals? Those are both used to help us maintain our balance. What is the function of the cochlea? The cochlea is where hearing actually takes place. Okay, and then moving on, what is this bony region, regardless of whether we're talking about the semicircular canals, the vestibule, or the cochlea, what is this bony area called on the outside? That area is known as the bony labyrinth, and resting inside of that, what is this area called? That's going to be the membranous labyrinth. Moving on into the cochlea, which again, we just took a slice right here and we're looking at this region. What is this area called? That's going to be known as the scala vestibuli. What would this region be called? That's going to be the scala tympani. What would this region be called? That's going to be the cochlear duct. So again, just to bring everything together to make sure that you fully comprehend this, the scala vestibuli and the scala tympani are part of which labyrinth? The bony labyrinth or the membranous labyrinth? The scala vestibuli and the scala tympani are both going to be part of the bony labyrinth, which then leaves us with the cochlear duct comprising the membranous labyrinth, at least inside of the cochlea. Name this membrane right here. That's going to be known as the vestibular membrane. Again, it makes sense that this is called the vestibular membrane because it's connected to the scala vestibuli. Name this membrane down here. That's going to be the tympanic membrane, which again makes sense because the tympanic membrane is associated or connected to the scala tympani. Name this membrane right here. That's going to be known as the tectorial membrane. Name these cells right here. Those are going to be known as hair cells. And name these structures right here associated with the hair cells. Those are known as stereocilia. Name these cells right here. Those are known as supporting cells. And then these nerves that run from the hair cells will eventually converge to become which nerve that we see right here? That's going to be the vestibular cochlear nerve, also known as cranial nerve number 8.
All right, so there you have it. That was the ear. I hope it wasn't too difficult for you. If it was, though, you can always use this resource as many times as you want. Keep going back to the lesson, follow it up with the testing portion, and I'm sure you'll have it down in no time. So best of luck to you on your exam, and hopefully I will see you again soon in another anatomy video.